Given f of x equals x times the square root of 1 minus x squared, let's find the critical points and the relative extrema. So I'm going to rewrite this as x times 1 minus x squared to the 1/2 power. And then I'm going to take the derivative by using the product rule. The derivative of x is 1 times second, so that's square root of 1 minus x squared, plus, now let's take the derivative of the square root. That's 1/2 times 1 minus x squared to negative 1/2 power, and then chain rule says multiply by the derivative of the inside, which is negative 2x. And then we're going to multiply by x. So we have 1 minus x squared to the 1/2, and then the 2's are going to cancel here. We have minus x squared over 1 minus x squared to the 1/2 power. So I'm just going to rewrite this as a square root of 1 minus x squared minus x squared over the square root of 1 minus x squared. I'm going to multiply the first term by the square root of 1 minus x squared over square root of 1 minus x squared to get common denominators. So we have 1 minus x squared as the first, because the square roots cancel, minus x squared all over the square root. And then simplifying this, we have 1 minus 2x squared over the square root of 1 minus x squared. So for the critical points, we want to look at when the derivative is equal to 0 or undefined. So basically, we're just going to set the numerator and denominator equal to 0. So for this one, we'll add the 2x squared divided by 2, and then square root to get x is plus or minus 1 over root 2. This one will square both sides, add the x squared, square root, get x is plus or minus 1. So now we'll plot this on the number line. And then we'll just plug in different values. So recall that f of x is equal to x times the square root of 1 minus x squared. And for the domain, we want to make sure that the square root is not negative. So just to help us out, we want 1 minus x squared to be greater than or equal to 0. And then 1 minus x squared looks like this. So basically, you want to make sure x is between negative 1 and 1. So we're going to say that negative 1 and 1 are the end here. So we don't need to look at anything beyond that. So we just need to test a different region. So we pick a number between negative 1 and negative 1 over root 2. We see that it is negative. And then let's say if we pick 0, that's positive. And then pick a number here that's negative. So you can plug it in, but just to save some time, this is what it looks like. And so this is the first derivative number line. So if the derivative is negative, it's decreasing. Positive, it's increasing. So at x equals negative 1 over root 2, we have a local min. And at x equals 1 over root 2, we have a local max.